Hello and welcome to this the first concept of descriptive statistics, which is the mean of the average. We're gonna explain with details the concept of average or the mean, because one of the most fundamental concepts in descriptive statistics or central tendencies. So let's start with the definition. The mean, often referred as the average, is a measure of central tendency that represents the sum of all values in the data set divided by the number of values. Okay, it's a common way to summarize a data set with a single value that indicates a typical value. So when we measure the central tendency of the mean, we summarize a data set with the single value, the most common value, or the typical value. In order for us to calculate that, we represent the sum of all values in the data set divided by the number of values. Let's give a quick example on that. Let's say, for example, a score in the subjects of high school students. For example, we have 5 subjects, and the score of in terms of percentage. So, for example, the first subject he had, or he has, or she has, for example, 75%. Okay. In the second one, he has, for let's say, he has 90%. And for the fifth, he has, for example, 87%. For the fourth, he had, let's say, 79.2%, and for the fifth, he had 66%. So the formula for that, the formula to calculate the average or the mean of the central tendency that represents the typical value, we sum all of these values divided by the number of values. Here we have 75 in terms of, because we have quantities, we have the measure in percentage, because we have the score of high school students in the percentage. So we add all of them divided by the number of them, which is five scores. Okay. So for us to calculate that, we call for the formula of the average, which is sigma or to represent the formula of average, we call it x bar equal to sigma, which is the sum, equal to number of them. It starts from one value to the n value. Then represents the value, for example, the first one, the second one, the third one, etc., divided by the n value, which is the total number. which is here in our example is 5. Okay, so this is the formula we use for us to calculate the average. So let's apply that. So let's apply that. Here we have the number of values, which is the number of values. We have 60. We add them together. 65 plus 90% plus 87% plus 79.2% plus 66% divided by all of them, which is give us 5. This is gonna give us, let's take it which one other. If we add 75 plus 90 plus 87 plus 79.2 plus 66, it gives us 39.72. 397.2 divided by 5. It gives us 69.44%. This is the average score of this student. So that means he has an average of 79.44% in score of all subjects. This is the average. This is the typical value. This is one of the the fundamental concepts in central tendency. Let's apply that in Excel file. So now let's apply what we learned in terms of the central tendency measurement of average or the mean or the typical value in this data set. Excel gives us the direct data by calling for a function. Okay, so we have here a data set on medical blood pressure of 100 patients, and here the column of age, because the age is a factor of that contribute to that the age is one of the factor of cardiovascular risk, systolic BP, diastolic BME, and the cholesterol levels. We have all these columns. Let's call, for example, or the average of them. So let's call here for. Let's go down here and call for average. Here we call for the columns. Okay, so here if we want the average age of these patients, we call for average formula. Then we're gonna select V2 in all to B2 to B to B. We select to B 101. Then we're gonna close the formula, then enter. Then here we have it. The average age of these patients is 53 years. We're gonna generate that by going down in the corner, and we're gonna have here the selected for systolic BP. We're gonna explain these factors later to answer statistical problems for these patients, for them to in which about these measurements or these factors that give them the risk of cardiovascular disease. Which of them have cardiovascular risk? Which is yes, we call it for 1, and 0, no. Okay, because all these columns here, systolic BP, diastolic BP, BMI, cholesterol levels, we call all these factors can contribute to cardiovascular risk. Okay, so that's why we call for these measurements of these measurements of these medical concepts: systolic, diastolic, BMI, and the cholesterol levels. Here in the average systolic BP millimeter per hectogram is 140.33. Diastolic is give us 90.647. BME is 28.427, and the cholesterol levels is 218.370. So don't bother yourself with that, because as a data analyst or as a future data analyst, data scientist, or business analyst, I'm gonna give detailed and simple explanations about these concepts and how they related to cardiovascular risk. So we can have when we move on to more statistical analysis, we can give answers in the meaningful insights. We can give meaningful answers. So this is it. This is the average. It's for age. It's 53.42. The systolic BP 140.335. Diastolic BP 90.647. BMI 28.427. And cholesterol 218.370.